Of a cube root function. All right, so we got 3n plus 2, that's in parentheses, and this 1/3, this exponent here of 1/3, is just telling us to take the cube root. The 3 is the index, that's the root we're taking, and the 1, the numerator, just tells us what power we're raising the radicand to, which in this case is just the first power. All right, well, let's start solving this thing. Well, let's subtract 1 from both sides. So now we got, and if this makes you feel better, you could write it like this. Don't have to, but you could. Now equals -1. And let's take the cube root of both sides. I mean, not cube root. Let's cube both sides. Excuse me. Well, over here, that's going to cancel. It's going to leave us with 3n plus 2. And let's see, what's -1 cubed? -1 cubed is just -1, isn't it? All right, well, what do you say we subtract 2 from both sides? Now we got 3n equals -3. And if we're going to divide both sides by 3, then we're left with n equals -1. Nasty looking n. All right, but do I want to check my work? Yeah, I think I do. Well, let's think about this. Let's see. If I substitute in 1, or excuse me, -1 for n, we're going to take the cube root of that. Well, let's see. 3 times -1 is -3 plus 2. We still got to take the cube root of that plus 1. So I've got, I'm going to write it like this, -1 cubed plus 1. What's -1 cubed? Cube root, excuse me. I keep saying it the wrong way. What's the cube root of -1? Well, it's just -1. And -1 plus 1 is 0, and 0 does in fact equal 0. So n equals -1 is a valid solution. Now, let's look at one that might be a little bit more interesting. All right, here I got 3 times 5y minus 1, cube root of that, raised to the power of 1/3, minus 2 equals 0. Well, let's start by adding 2 to both sides. So now I got 3 times 5y minus 1, we're taking the cube root of that, equals 2. And now I want to divide by 3, so I got 5y minus 1, of which the cube root of that now equals 2/3. Well, let's cube both sides of this thing. All right, well, my cube root and my cube are going to cancel, leaving me with 5y minus 1 equals, let's see, I got a cube 2/3. What's 2 cubed? 2 times 2 times 2 is 8. What's 3 cubed? 3 times 3 times 3 is 27. So now we got 5y minus 1 equals 8/27. And let's add 1 to both sides. Then I'm going to have 5y equals 8/27 plus, well, I'm adding 1, right? Well, 27/27, I need a common denominator if I'm going to add those. So now 5y equals 8 plus 27 is 35/27. I'm going to rewrite that right there. So now we got 5y equals 35/27. And now I need to divide by 5. But, you know, that's the same as multiplying by 1/5, isn't it? So now y equals 35/27 times 1/5. Well, I'm doing a little bit of simple reduction here because 5 will go into 35 7 times. And so y is going to equal Well, 7 times 1 is 7. 7, and this is 1 now. 7 over 27. Wow. But you know what? I need to prove this. I need to substitute that back in. Getting to this point wasn't that bad. When I look at putting in 7 over 27 for y, that looks interesting. So let's try that. Now I got 3 times 5 times, let's make that a bracket, 7 over 27 minus 1, and all of that is taking the cube root minus 2, and I hope that's going to end up equaling 0. All right, well now we got 3 times, let's see, 5 times 7 is 35. So I got 35 over 27. 35. Right, let me make that 35 a little better. Minus 1. But if I'm going to subtract 1 from 35 over 27, why don't I go ahead and make this 27 over 27? Which is 1, right? We got to take the cube root of that. Minus 2, we're hoping that's going to equal 0. So now we got 3 times the cube root of, well, 35 minus 27 is 8 over 27. Cube root of that minus 2 equals 0. All right, well, what's the cube root? Let's see, we got 3 times. What's the cube root of 8? 2 times 2 times 2 is 8, so the cube root of that is 2. What's the cube root of 27? Well, 3 times 3 times 3 is 27, so the cube root of that is 3 minus 2 equals 0. And what is 3 times 2/3? Well, Shazam, that's going to be 2 minus 2. And how about it? Does 0 equal 0? Has for most of the lifespan of mathematics. And so we do have a valid solution that y equals 7 over 27. Exciting, right?